Alright, in this science video we're going to talk about potential energy. So if you watched the last video, it was about kinetic energy. This is another type of energy called potential energy. It's really totally different than kinetic energy. Kinetic energy, we were dealing with motion. Potential energy has almost nothing to do with motion. So potential energy is the energy an object has due to its position or condition. Alright, so I know that's a little vague. We're going to get into some of the details of what that means. But this potential energy is stored energy that's not necessarily being used at a given time, and it's based on what an object could possibly do. So this is stored energy that we're going to see what can we do with that energy. All right, so there's different types of potential energy, but they all have to do with what an object could do because of how it is arranged or what position it's in or its condition. All right, so let's look at a couple of examples of this. One major type of potential energy is gravitational potential energy. So what gravitational potential energy is the energy something has due to its height above the ground. So anything that's elevated above the ground has potential energy. So something that's sitting on the roof of a building would have potential energy. And if we think about this, what does it have the potential to do? It has the potential to fall and accelerate downward. So how this works is the potential energy could be used to accelerate the object downward. So again, potential energy is all about what an object could do. So what affects gravitational potential energy? The mass of an object and its height above the ground. So the higher up an object is, the more potential energy it has. So an object, if we take a football that's sitting on top of the Empire State Building, it's going to have a lot more potential energy than a football that's sitting on top of your house. So the higher the height, the higher the potential energy is. And also, the more mass an object has, the more potential energy it has. So if on the roof of your house you take a golf ball and a bowling ball, the bowling ball will have more potential energy than the golf ball, even though they're at the same height, because the bowling ball has a greater mass. So both mass and height have a positive relationship with gravitational potential energy, meaning that if we increase either of these, the potential energy is going to increase as well. So the formula for gravitational potential energy is 10 times the mass times the height. This 10 is an approximation. It's technically 9.8, but for our purposes, we're going to use 10 just to make the math a little easier. So to calculate potential energy, it's just 10 times the mass of the object times the height of the object. So we can tell by this formula as well, if we increase the height, if we multiply by a bigger number here, that's going to give us a greater potential energy. And same thing with the mass. If we increase the mass, multiplying by a bigger number, that's going to give us a bigger potential energy. So both mass and height, if we increase either of those factors, we're increasing the potential energy. So, thinking about that, let's maybe take a moment, pause the video, and see if you can rank the positions as this ball moves from A to B to C to D, E, F, and G through this loop here. Rank the potential energy at each position from highest to lowest. So pause the video and do that, and you can come back and check your answer. So all we want to look at in this case is what is the height. We said the two factors of affecting potential energy are mass and height. So the mass is obviously it's the same ball, the mass is staying the same, so what's changing is the height. So the higher the object, the more potential energy it has. So the highest here, from highest to lowest, the highest is going to be object A, because you kind of have these benchmark lines here to guide you, but A is higher than G, so it's going to have the highest potential energy. The next highest would be G, so G would be the next highest. Then we can take down from here B, F, C, E, and D from highest to lowest. So again, potential energy really, and gravitational potential energy really only has to do with the height of an object. So the higher it is, the more potential energy it has. Alright, so which has greater potential energy? A roller coaster moving slowly at the top of a hill, or a roller coaster with a high velocity at the bottom of the hill? So think about this for a second, pause the video, come up with an explanation, and you can check your answer. So the potential energy only depends on the height. So the fact that this roller coaster is moving slowly does not matter. The fact that this roller coaster has a high velocity does not matter. If we were asking about the kinetic energy, then we could think about those things. But for potential energy, all we care about is the height. So the roller coaster at the top of the hill versus the roller coaster at the bottom, the roller coaster at the top would have more potential energy because it's higher up. And with potential energy, we only care about the height and not the speed. So in this case, the roller coaster at the top would have a higher potential energy. So we've got some calculations here. We have two rock climbers scaling the face of a mountain. One has a mass of 50 kilograms and he climbs to a height of 20 meters, and the other has a mass of 80 kilograms and climbs to a height of 15 meters. All right? So to find which one has the more potential energy, we just have to plug both of their data into the potential energy formula. So 10 times the mass times the height, we have all the information we need here. So we do gravitational potential energy equals 10 times the first guy's mass is 50 and his height was, 50, not 15, and his height was 20. I'm just going to write 50 down there. I know that's impossible to read. Okay, so 50 for his height and 50 for his mass and 20 for his height. So all we have to do is multiply our three numbers here. So this would give us 10,000 for the gravitational potential energy for the first guy. So again, we're just multiplying his mass by his height by 10 and getting the potential energy. So we do the same thing for the second guy. 10 times his mass, which is 80, times his height, which is 15. So this would give us a potential energy of 12,000. So again, you can check that in your calculator, but this would give us 12,000. And our units for energy are joules. So which has the higher potential energy? It would be climber B. So just based on the calculations we did there. So the gravitational potential energy formula is pretty straightforward. We just have to plug in our mass and height and multiply across. Alright, so I want to close the video by talking about a couple of other types of potential energy. So another type of potential energy, aside from gravitational potential energy, is elastic potential energy. So remembering that potential energy is all about what something could do, elastic potential energy comes from something that's stretchy, either a rubber band or a spring or anything like that that's stretchy or elastic. And if we stretch these objects out or compress them, that's what's going to give them potential energy. So if we think about a spring, and let's say we take that spring and we stretch it out really far, what's this spring going to want to do after we stretch it out? Well, if we pull it apart, it's going to want to snap back into place and return to its original shape. So that's what gives this elastic object potential, is when we stretch or compress it, it has the potential to snap back to its original shape. So again, potential energy is all about what something could do because of the position we're putting it in. Alright, the last type of potential energy we're going to talk about is electric potential energy. So this is energy that results from the position of objects that have charge. So again, the different types of charges that we could have would be positive charge, negative charge, or neutral charge. So if an object has charge, if we look at the top part here and we have two positive charges and we put them near each other, what's going to happen with these positive charges? Well, like charges repel each other. A positive charge doesn't want to be near another positive charge. They're going to want to push away from each other. So in this case, they're both going to want to go this way. So if we push these charges together, if we push them together, they're going to want to spread apart. All right, so we're giving them the potential to spread apart by the position we're putting them in. And same thing, if we have a positive and a negative charge, if we put them near each other, they're going to want to come towards each other because opposite charges attract. So by putting them near each other, we're giving them the potential to come towards each other and move because of the energy that they have. So all of these types of potential energy, elastic, electric, and gravitational potential energy, they're all about what an object could do. So an object that has gravitational potential energy could fall down to the ground and accelerate. An object that has elastic potential energy could snap back to its original shape. An object that has electric potential energy could have the charges move because of how they're arranged. So potential energy, in summary, is all about what an object could potentially do. Alright, thanks for watching this video, and I'll see you in the next one.